Welcome back to geometry. We want to continue taking a look at section 25, transformational geometry. And we want to look at a little bit more on isometries. All right, so it works out, as I previously mentioned, that every isometry, if we have an isometry, then it is necessarily going to be one of the four isometries that we have now discussed. So it is going to be that F is an isometry if and only if F is a translation, a rotation, a reflection, or glide reflection. So with this idea, if we have two congruent figures, we talked a little bit previously about we can replace side angle side with the idea of congruence based on two figures matching, two geometric figures matching. And now that I'm thinking about it, I'm not sure that we really talked about that too much. No, okay, I guess this is where we develop it. That's fine. Okay, so with this idea, every isometry is one of these four, right? Translation, rotation, reflection, or glide reflection. And if we have two congruent figures, we must be able to get one of them from the other using one of these transformations. Okay. So an idea here that we want to revisit is orientation. We have that translation and rotation preserve orientation of a geometric figure, while reflection and glide reflection do not preserve the orientation. So if we want to consider how two geometric figures are congruent, right, which of these transformations map one to the other, if the orientation is preserved, we know it has to be a translation or rotation. Usually a translation is pretty obvious compared to a rotation. And if the orientation is not preserved, then we would actually have that it must be a reflection or a glide reflection. And when there's no obvious line of reflection, then it would have to be a glide reflection. So we'll take a look at this shortly. There are a couple of special circumstances in which we have symmetry. There are lines of symmetry in a figure, and we're going to ignore that for now and move on to that in the video shortly. So, all right. So we'll take a look at an example of determining how two congruent figures are related to one another. What transformation takes us from one to the other? So let's consider each pair of figures given in this example, and let's find the transformation that takes us from one to the other. Now, of course, we're not looking for the exact formula, we're just looking for the type here. So we consider two of them at a time. So if we want to consider A and B, to go from A to B or B to A, let's see here. First thing we can check is for the orientation, right? The easiest way to view this is if we have the ground, we have a flag pole, and we have a flag going to the right. So if we have the ground, we have the flag, and we have flag pole, and then we have the flag going off to the left. So orientation is not preserved, right? We have a flag that's pointed to the right, and then we have a flag that's pointed to the left. So orientation is not preserved in this case. If we wanted to, we could observe points A, B, C, and then points A prime, B prime, and C prime, as we had discussed the orientation previously. And then traveling A, B, C would give us clockwise rotation, and traveling A, B, C would give us counterclockwise orientation. So you could do this for each of them, or you can look at, think of it as which way is the flag pointing. However you want to think about it is fine. In either case, you should find that when you compare A and B, they do not have the same orientation. So this has to be a reflection or a glide reflection. And we might notice that, hey, look, that line right there looks like it could be a line of reflection. So AB is given by a reflection. Right? We can obtain B from A using a reflection. All right. So notice here that there are 7 figures, A through G. So we need to make all of the comparisons here. There are quite a few to go through. I wanted to get rid of that line there. So this was a reflection. All right, let's look at AC then. To get from A to C, you might notice that we have a flag to the right and a flag again to the right. So in this case, a orientation is preserved, so it either has to be a rotation or a translation. Clearly, we didn't just slide this down, so this must be a rotation. All right, next would be AD. Right, I'm choosing these in a particular order to make sure that I get them all. So I'm comparing A to B, C, D, E, F, G, and then I'll compare B to C, D, E, F, G, and so on. So comparing A to D, right, let's see here, we have a flag pointed to the right, flag pointed to the right. And so the orientation is preserved. It's not just sliding it over. So we must have that AD is a rotation as well. All right, and then we have AE. All right, where do we have E is way over here, comparing A to E, flag pointed to the right, flag pointed to the left, and it looks like that could be a line of reflection, right? Because it has to be a reflection or a glide reflection. Looks like this could be the line of reflection, so we'll say it's a reflection. All right. Next would be F. So comparing A to F, we have flag pointed to the right and a flag pointed to the left. So the orientation is not preserved. So it must be a reflection or a glide reflection. And since there's no obvious line of reflection in this case, we would say that it must be a glide reflection. All right, and then finally AG, flag pointed to the right, flag pointed to the right, preserves orientation, and it looks like it could just be, bam, we slid it down. So it appears to be a translation. All right, so that takes care of A compared to everything. So now we start comparing B to everything. We already compared B to A, so we move on to C, B to C. Now this is a flag pointed to the left, and this is a flag pointed to the right. So orientation is not preserved, and there's no obvious line of reflection. So comparing B to C, we would say that it is a glide reflection. All right, so next would be comparing B to D. Compare B to D. This is a flag pointed to the left. This is a flag pointed to the right. Right, we've got to turn this thing upside down, right? If this were the flag pole, if it were standing up, it would be a flag pointed to the left. This, if it were a flag pole standing up straight, this would be a flag pointed to the right. So it does not have the same orientation. And since it does not have the same orientation, it must be a reflection or glide reflection. In this case, since there's no obvious line of reflection, we would also call this a glide reflection. All right. So BE, compare B to E. All right, so this is a flag pointed to the left. This is a flag pointed to the left. Preserves orientation. It does not appear to be a translation, so it must be a rotation. Now, I'm not saying I know where exactly the center is. We could find that, but as for now, I haven't bothered, right? That's not what I'm trying to say. All I'm trying to say is what connects these two things. What transformation can I use? Okay, so B to E would have to be a rotation, since it's clearly not a translation and its orientation is preserved. So next would be BF. So comparing B to F, flag pointed to the left, flag pointed to the left. It must be a rotation again, since we don't have an obvious translation. So that brings us to BG, comparing B to G. Flag pointed to the left, flag pointed to the right. No obvious line of reflection, so this must be a glide reflection. Excellent, so that's about half of them. So we've gotten through A and B. Next would be comparing C. So we've already done CA and CB. So next is CD. So to get from C to D, it seems pretty clear here. Flag pointed to the right, flag pointed to the right. They're not far off from one another. No, it's not. So orientation is preserved, and we don't have it being an obvious translation, so it must be a rotation. All right, next would be CE. To compare C to E, we have a flag pointed to the right and a flag pointed to the left. So orientation is not preserved, so it's either a reflection or a glide reflection. No obvious line of reflection here, so it must be a glide reflection. All right, CF is next. Flag pointed to the right, flag pointed to the left. Orientation is not preserved, and there's no obvious line of reflection. So again, we have a glide reflection. And might as well give you guys an opportunity to give it a shot. So I'll let you complete the remainder of them. We've done more than half of them already, and I'll even tell you what the remaining ones are. So we have CG left, DE, DF, DG, EF, EG, and FG. So that's 7 for you guys to determine on your own. And you should see each of a rotation, glide reflection, translation, and something that appears, it's really, really close. You could call it a glide reflection, but I think there's what appears to be a relatively obvious line of reflection, so you could call it a reflection. So you should see all 4 in the remaining 7. So I would encourage you guys to finish those out. All right. So just a couple things left to look at before we finish this video. So we have the reflection postulate, and this is the postulate that we could replace the side angle side postulate with. Okay. Essentially, what it amounts to is, right, as far as triangles go, side angle side postulate is what gives us congruence, other than matching all of the side lengths and all the angle measures. So we could remove that postulate and we could replace it with this postulate, the reflection postulate. So for every line L in the plane, there is a transformation F called the reflection over L such that if P is on the line L, then F of P is equal to itself, right? If it's on the line of symmetry, it doesn't go anywhere, or the line of reflection, rather. If P is not on the line of reflection, then F of P is on the opposite side of L compared to P. And then furthermore, F preserves distances, collinearity, and angle measures. So these are the things that, right, this last bit we already talked about, our transformations, all of them are isometries, preserve distance, collinearity, and angle measure. But this axiom only refers to reflections, and we'll see what that's all about in just a moment. But with this reflection postulate, we can give a different definition for congruence for triangles, for rectangles or quadrilaterals, five-sided figures, all polygons. We can give a congruence condition based on transformations. So we can replace the side angle side. But to do that, we have to have a better understanding of what or a different definition of congruence would be handy, we'll say. So two polygons are congruent if one can be transformed into the other using only translations, rotations, reflections, and glide reflections. Excellent. So if we do that, the reason that we would if we look at this definition for congruence and we consider this particular axiom, the reflection postulate, the reason that we could no longer consider, the reason that we could replace the side angle side with this is because if we assume this postulate, then we can actually prove the side angle side congruence condition. Okay, so it would become a theorem if we were to first assume this axiom or this postulate. All right, so you might ask yourself, why does our axiom axiom 16, the reflection postulate, only consider the isometry of reflection? Well, that is under consideration for the following activity. So I would encourage you guys to complete this activity. And there's a couple of comments that I want to make about it, right? It's a relatively, well, it's not a short activity, and there's two of them actually. So composing reflections over parallel lines, and then composing reflections over non-parallel lines. And when you perform this, when you perform these reflections, you'll be able to come up with some conclusions, make some observations, and it will actually provide for you the completion of this theorem. So any isometry of the plane can be expressed as a composition of something. And if you're still not sure what it should be after you complete the two activities, read the comment below, which should further solidify your observations. So I'll leave those for you guys to consider. And in the next video, we'll pick up at symmetry. So again, thank you for your time, and I'll see you guys again here soon as we continue talking about transformational geometry.